Hey everybody, I wanted to do a quick, maybe not so quick, 10 minute, 15 minute me working on a flow chart. It's a different problem, but maybe it'll help you as you're sort of struggling with your flow chart. Remember that you can always get learning specialist support, and you can reach out to me by text is faster than email, but either way to sort of try to arrange a time to talk. Okay, here's the challenge. Let me share my screen. Screen three. Here's my blank draw to IO diagram, and here is my little description of the problem. Zoop. Um, if there's a way to just put that into the text. Oh, here, it looks like some text. And then I'll go here. Oops. And I'll go here. Copy this. And I'll go to here. Paste it. Whoa. Okay. Um, and maybe I'll bring up that little um, PDF of the flow chart, which is still available for you. But this document here, right, has a little bit of a description of the pieces of the flow chart. Okay, so let's start with the terminal. Start. And I need some input, so that's going to be my next shape. I'm going to say take in array named ARR. And value to search for in. Right, make this a little bit bigger. And I'll take this up here, and then we'll connect here to here. Great. All right, so I've taken in my input, and the first thing is going to be a process, and that's just going to be sort ARR. I don't, depending on the language, there may be a really easy way to do that, but basically I'll call this sorted array. Okay. Right. So we're going here and we are sorting, and now we've got sorted ARR, which is the middle, the array, but in order, right? So if I was imagining, um, I had kind of a mixed input of 2, 3, 4. Wait, let me do some writing here. So I'm thinking if I had an array that was like 2, 3, 4, 10, 1, the sorted array is going to, what's coming out of this would be 1, 2, 3, 4, 10. All right. Okay, so just going to move this over here so I can kind of think about that. So what's happening next? Well, I need to know where the middle of the array is, and I can look at the length of the array, and then so this is going to be another process, but I'm going to use just the plain rectangle because I don't know that I would abstract this into a separate thing. I just write some code to do this. Find the length of sorted ARR and save as variable. L, let's just call it length, and then divide length by 2 and round to an integer and call midpoint. Okay, so in the case of this, this is 5 elements long. I divide it by 2, that's 2.5. I round it, that's 3. I'm wondering, in the case of 3, index 3 is the number 4 here. I'm wondering if I should just take away 1, round to an integer. Let me consider a even number to see whether. Okay, so if I have, instead of that, if I have an even number of elements, 24, 26, 30, 38, 50, 52, that's 6 elements. So if I take the length 6 divided by 3, sorry, divided by 2 is 3, element 3, 0, 1, 2, 3. And then, and in this case, there is no middle element. So how do I want to do that? Well, at this point, I think that I don't really need to worry about it so much, because basically the concept is that I'm breaking my array into 2 parts to make it easier and faster to find a match. So in the case of an odd one, I'm going to end up 1 to the right of the center. In the case of an even one, I'm going to end up in the center, but on the right value. So I think I can just use this index, look at, this is going to be a condition now. So I'm going to get rid of this, and so the question is sorted ARR bracket midpoint the same as the target n? Okay, and then from there, I've got a yes and a no. So if yes, then I actually have found the answer and I'm ready to exit the program with the output of, so type yes, output true, and then I'm going to go to the ending. Okay. But more than likely, it's not going to be the same thing, in which case I need to ask another question, which is sorted ARR bracket midpoint bracket less than n? So let's use this as our example. Let's say we were searching for the number 40. 40 is not in here. I can see it with my eyes, but I want to be able to go through this process and end up coming out with the output false. So at this point, I took my array, I sorted it, I found the length, which was 6. I divided by 2, that's 3. That's the variable called midpoint. Then I look at sorted array 3. Sorted array 3 is the number 38. Is it the same as n? No. Is sorted array 3 less than n? The answer is yes. So then at that point, I can So the answer is yes. So yes should be going to a rectangle. Let me type the word yes here. And in this case, I want to take a subset of the array from index 0 to midpoint -1 and let that be equal to sorted array. So what I'm doing is I'm replacing sorted array. Sorted array used to be this. And now what sorted array is going to become, let me go back to my annotation tool. Sorted array is going to become, in the next iteration, if I'm looking for 40, oh, this is backwards. Because if the number sorted array midpoint is less than, I want this to be my new subarray. So sorted array should be equal to 50, 52, and then I can repeat the process. And I may need to put another decision maker in here. But anyways, I'm just going to change this yes to no, because this is what I want to do in the case of no. And I need to have another one coming out here, which is going to my rectangle. And that's then going to take the subset of the array starting from index midpoint +1 to the end of the array. Okay. Again, I'm not worried about this sort of technical aspect of how that's going to be accomplished. I'm just imagining what I need to do. So now I have this piece. And I think if I, oh, sorry, I need to point out that this will be, and let that be equal to sorted array. So then I think I can feed back into this part. So let me move some stuff around here. I'm gonna move this over 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 here, much closer. Got my yes coming here. Be all crazy. Okay. So no goes there, yes goes there. Right. Now this one is going to come and hook back into this. And this one is going to hook back into this. Okay. So find the length of the sorted array and save as a variable length. So the length is 2. Divide the length by 2, that's 1. Round to an integer, still 1. Call the midpoint. So now I'm calling this the midpoint. Is the sorted array midpoint the same as n? The answer is no. I never labeled this. No. Is sorted array midpoint less than n? The answer is no. It's not, because n is 40, and so 52 is not less than 40. There needs to be a decision here, because I would like to be picking more elements to the right, but there aren't any. So this needs to happen only if there are more elements to the right. So I guess the question I would need to ask then is something like, are there more elements past the midpoint? And again, the nice thing here is I don't really need to worry about how I would accomplish answering that question. As long as I can understand the question, I can do it. So then the no actually needs to hook into here. And this thing could be a way out, which is my output false. And output false can hook to there. And this guy, one of the possibilities is that we go to here. Are there more elements past the midpoint? No. Output false, and then yes is the part that takes me back to here. And then in this case, before I go here, I want to ask the question, so I'm going to take this, I'm going to put another diamond in here for another decision. Just reverse the question. Are there more elements for the midpoint? And if the answer, so this instead goes to here first, and then our no means we're hooking into the output false, and our yes means we're going back to that process. Yes here, no here. Woof. All right, I'm ready to test it. I think this is working, but the testing is important, and the testing is mental. So I'm going to run through the process, and I'm going to use a larger array to kind of help myself. So back to my annotation tool, clear all my drawings, text box. Okay, here's my array. I'm just going to go with the sorted array, so I don't need to think about that because I have a process that takes in whatever array I give it and returns the sorted array. So let's say I have 2, 5, 12, 16, 19, 46, 94, 120, 112, 123, 145, 287, 1,180, whatever. All right, how many elements is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be my sorted array. And so then the next step would be finding the length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Length is 12, midpoint is 6, sorted array bracket 6 is, let's see, 0, 1, 2, 3, 4, 5, 6, 94. Okay. Oh, I didn't come up with a number. Let's say I'm looking for the number 5. Sorted array is that. I'm looking to see if 5 is in the array. Okay. So now we're ready to ask the question. Is sorted array midpoint the same as n? No. Is sorted array midpoint less than n? No. Are there more elements? Is sorted array midpoint less than n? Sorted array midpoint is 94. 94 is less than 5. False. No. Are there more elements past the midpoint? I think I got this backwards. Yes, this is backwards. Let me get out of this. Are there more elements before the midpoint? Are there more elements after the midpoint? Okay. Okay, so back to my annotation. Picking it up here. So is sorted array midpoint less than n? No. Are there more elements before the midpoint? Yes. Take a subset of the array from index 0 to midpoint -1. So midpoint was 6, midpoint minus 1 is 5. So I'm going from index 0 to 5. So now my new sorted array is 2, 5, 12, 16, 19, 46. Okay. And now I can repeat the process because I'm feeding back into here. Find the length of the sorted array, 6. 6, midpoint is 3. Is sorted array midpoint the same as n? So sorted array midpoint would be 16. Sorted array 3 is 16. And so now we're ready to ask the question, is 16 less than 5? Answer, no. Are there more elements before the midpoint? Yes. We repeat the process, keep going. Okay. I need to like delete some of these things. So I'm going to highlight this, delete that, highlight this one, move it up here. So now sorted array is 2, 5, 12, and the length is 3, and the midpoint is 1.5, which we round up to 2, and sorted array 2 is 12. This is where my thing is not working optimally because I should be in the middle of this, not on the one above it. But I'm not going to take the time to fix that. Sorted array 2 is 12. I can go back through the process. So is sorted array the same as n? Is 12 the same as 5? No. Is sorted array 12 less than n? No. Are there more elements before the midpoint? Yes. So now we're back. So I could this. I'm feeling pretty good about this. Boom. This one I'm going to move up here. And last, sorted array equals 2, 5, and the length is 2, so midpoint is 1, and sorted array 1 is 5, and we're going to get out of here, output true, end. Right. Okay. This is way more complicated than the task you have, but a couple of key points here in my thinking about it. First of all, the problem is clear to me. I mean, I understand the goal of what we're trying to do, so I was able to kind of move forward piece by piece. I'm operating on the things that I have access to. So in this case, I started with ARR and n. I made a new variable called sorted ARR. I made some more new variables, length and midpoint, and I'm referencing things sort of one at a time. One of the challenges that some people are having in thinking about this is saying, tasks or processes which sort of go beyond what exists in accessible variables in memory. So for instance, if you have a specific number and you're trying to see whether that particular number is divisible by 5, that's a question that I can answer specifically yes or no. If you write a process that's like find all of the numbers that are divisible by 5, that's essentially a task you're trying to accomplish, but that's not an appropriate element of your flow chart because that's what you have to do. You have to spell out how that would be accomplished. So anyways, hope this was helpful. I do want to build this and make it a little more optimal and then kind of show you, the difference in terms of performance of the binary search versus the regular search. I mean, I don't need to do all this crazy stuff. I could just go through one element at a time and see if the element is equal to the thing I'm looking for. But binary search should save us a considerable amount of time because we're sort of cutting things in half to see whether we care about this half or this half, and that should get us to the answer faster. All right, but I got to remember how to do timestamps in JavaScript. So anyways, we'll see if I can get around to that. All right, hope that was helpful.